All right. So what we're going to do is review a little bit of question and answer, just so we can get familiar with some of the content we've gone over the past few days. This is a little rudimentary, but I thought this might be useful for anybody who appreciates it. So this is from chapter 2. All right. And if you give me a moment, we'll be able to get this stuff going, and everyone should be very excited. Uh, Basically, the Google security exam is very rigorous, and a lot of the material there should be covered from the previous audiobook chapters. So these will go over the concepts, understand what can be answered, how you should think about it. So to meet PCI DSS requirements, which two offerings ensure all outbound traffic is authorized without additional compensating controls? Compute Engine and Google Kubernetes Engine. PCI DSS compliance requires strong control over outbound, meaning egress network traffic. Among GCP offerings, Compute Engine and Google Kubernetes Engine provide explicit control of egress network traffic through firewall rules. This enables strict authorization of outbound connections. So Kubernetes Engine and GKE inherently support strict PCI DSS requirements through configurable network controls. Next question. What's the network security responsibility model for G Suite, the SaaS service? Security is Google's responsibility, meaning Google Cloud clearly defines the shared responsibility model. Google manages virtually all layers of infrastructure, platform, application security, and network security. And customers are responsible for user accounts, credentials, access policies, and not the underlying network security. So think G Suite is under Google's responsibility, meaning all the infrastructure and actual physical property is under theirs. What they control on that hardware is theirs. The programmatic and management side of it, that is yours. And a shared security responsibility model for an IS, which two layers of the stack does the customer share responsibility for? Storage, encryption, and access policies. Why? In the shared security responsibility model for IS, infrastructure as a service, Google manages the hardware security, infrastructure security, physical security, and boot processes, including the Titan security chip for secure verification. The customer has shared responsibility for storage encryption. So while Google encrypts data at rest by default, customers can choose customer managed encryption keys or customer supplied encryption keys, therefore sharing encryption responsibilities. And there's also access policies, where customers can manage identity and access management policies and access permissions, defining who has access to resources and data. So storage encryption are the correct answers. To reduce PCI scope in a project that includes payment and non-payment systems, what should you do? Move cardholder data to a separate GCP project. Why? PCI DSS compliance involves isolating sensitive payment so that cardholder data from other non-sensitive environments. To significantly reduce PCI DSS scope, clearly separate payment from non-payment systems, move cardholder data into separate GCP projects that provide specific and explicit isolation. So this will reduce the compliance burden since only the project containing the cardholder data directly falls under PCI DSS scope. This allows you isolation of those resources and the ability to scope out what you need for non-PCI DSS compliant systems and data. Where can you find a summary of GCP's PCI responsibilities? The customer responsibility matrix. So Google will clearly define the shared responsibilities between customers and itself in a document called the GCP Customer Responsibility Matrix. It explicitly identifies what Google manages and what the customer must manage regarding PCI DSS compliance and other security protocols. Customers should definitely refer to this for clarity. A large financial institution is moving big data analytics to Google Cloud. They want maximum control over encryption at rest and in BigQuery. What technique should the institution use? Customer managed encryption keys. Why? It provides maximum encryption control suitable for BigQuery and allows for organizations to fully manage encryption key lifecycles and storage locations via Google Cloud Key Management Service. CMEK is recommended for organizations and requires significant control by leveraging Google's managed encryption infrastructure, meaning BigQuery is fully compatible with CMEK. A large e-retailer moves to GCP with its e-commerce site. It must ensure payment data is encrypted between customers, browsers, and GCP during checkout, which they do. Configure an SSL certificate on the L7 load balancer and require encryption. Yeah, that makes sense. For secure browser-based communications, that's HTTPS, Google recommends the HTTPS load balancer, which is layer 7, the application layer, with SSL TLS certificates installed. L7 load balancers terminate SSL TLS directly, providing secure encrypted browser-to-service connections and fulfills the requirements of securely encrypting payment information in transit. Okay. Which international compliance standard provides guidelines for information security control specifically applicable to cloud services? ISO 27017. So this specifically addresses cloud-based information security controls. It extends ISO 27001, adding specific requirements relevant to cloud computing environments. And ISO 27017 clarifies that cloud providers and customers share shared security responsibilities explicitly within cloud contexts. A business unit has created a cloud identity domain. Your team wants to take over auditing and permissions. What access should be granted? Organization administrator. Why? Because this provides complete control over Google Cloud resources and IAM policy administration across the organization. To manage auditing, permissions, and control, the cloud identity domain integration will do this comprehensively, and the role is necessary as it grants full administrative privileges at the organization level. That makes sense for a larger organization. If you want to let developers deploy apps without full network or security review, what should you do? Enforcing infrastructure as code, the statistic analysis in CI/CD. So to securely empower developers without slowing down development due to manual reviews, enforce infrastructure as code with static analysis tools integrated with the pipeline, and then you can automate the policy compliance checks before deployment, preventing misconfigurations proactively rather than reactively. If your company has many business units needing separate IAM and visibility, what's the best project setup? An org node and then folders per unit. That's makes sense. The hierarchy of an organization node with folders for each business unit allows clear separation of IAM policies, access control, and visibility. So folder level IAM and policies simplify administration and ensure proper inheritance and isolation for each business unit. How do you get a historical record of resources across all GCP projects? Forseti Security for inventory snapshots. So Forseti Security uniquely offers capabilities for historical snapshots of cloud resource inventories across all projects. Resource Manager or Stackdriver could provide current state information, but lack Forseti's historical snapshot capabilities. So this is essential for audit and compliance scenarios. So you're going to be your logging, your monitoring, it's going to be your best way to go. And asset inventory could also be a good complement as well. Your team needs to prevent users from creating projects in the organization. Only the DevOps team should create projects on behalf of requesters. What 2 tasks should your team perform? Create an organization policy constraint and apply it at the organization level. Add a designated group of users to this project, to the project creator role at the organizational level. So organization policy constraints explicitly control actions like project creation across the organization. And then assigning a project creator role only to the DevOps team ensures they're exclusively authorized to manage project creation. Your team wants to limit users with administrative privileges at the organization role. Which 2 roles should your team restrict? Organization admin and super admin. Why? Because org admin and super admin are very broad organization-wide administrative capabilities. This includes management of IAM policies, resource hierarchy, and security settings. And limiting these roles is critical to ensuring least privilege principles and secure organizational administration. You need to set passwords policies for cloud identity. What's the minimum password length? 8 characters. That is a good length, and it enforces a basic level of security. It's usually alphanumeric, maybe dashes, maybe underscores, but definitely alphanumeric. Your identity management team wants to keep using your existing Active Directory or LDAP server along with existing SSO passwords. What do you use? Google Cloud Directory Sync. Why? Because Cloud Directory Sync, GCDS, automates synchronization from your existing LDAP Active Directory server, enabling you to manage identities centrally without manual intervention. You have an internal app on Google App Engine and want to prevent external access, even if passwords are compromised. What should you do? Enforce two-factor authentication in G Suite or Google Workspace. Why? Because it adds an additional secondary verification step. This prevents access even if passwords are stolen. An organization is facing increased phishing attacks. What method protects employees' credentials effectively? Multi-factor authentication. Why? MFA significantly reduces risk from phishing attacks because compromised passwords alone aren't sufficient for unauthorized access. A customer needs automatic deprovisioning of a Google Cloud account upon employee termination. What should they do? Configure Cloud Directory Sync with Directory Service. Why? Because this automatically synchronizes directory changes, including deprovisioning, ensuring immediate removal of access. An organization wants their existing directory service as the source of truth. What solution meets this? Google Cloud Directory Sync. Why? Because it syncs with existing directories, maintaining external directory service as the authoritative identity source, single source of truth. You want to synchronize LDAP security groups with an email address into Cloud IAM. What should you do? Configure GCDS, Google Cloud Directory Service, LDAP search rules. So it's a one-way sync based on an email attribute. And so GCDS will support one-way synchronization, syncing groups with email attributes, and correctly provisioning groups into Google Cloud IAM. You have unmanaged personal Google accounts using corporate emails. You must leverage SSO and follow Google's practice to convert unmanaged accounts to be managed. That's single sign-on. What two actions should you take? Use Google Cloud Directory Sync and use Transfer Tool for Unmanaged Users, TTUU. GCDS synchronizes identities from your directory system. TTUU helps transition unmanaged Google accounts using corporate email addresses into managed accounts without data loss. Okay. Your team wants to centrally manage GCP IAM permissions based on Active Directory group membership. What should you do? Use Cloud Directory Sync to sync groups and assign IAM. Google Cloud Directory Sync enables automatic synchronization of Active Directory groups with Cloud Identity Google groups. This allows you to manage IAM permissions centrally through those synchronized groups. An app on Compute Engine needs to read from a cloud storage bucket using least privilege. What should you do? Use a service account with read-only access via instance metadata. A Compute Engine instance should use a service account attached to the instance metadata with minimal privileges, read-only, to ensure access without exposing credentials. What's the Google recommended way to rotate a user-managed service account key? Create a new key, update the app, delete the old key. The recommended practice is to first create a new key, then update your application to use it, and then finally delete the old key to ensure seamless and secure rotation. How can an internal app engine app access a user's Google Drive on their behalf without relying on the user's credentials? A service account with G Suite domain-wide delegation. Domain-wide delegation allows service account to impersonate users with Google Workspace domain, accessing resources like Google Drive without needing the individual user credentials. Departments each have Google groups. How can you ensure read-only access to new projects only within the department? Create a folder per department under the org, assign project viewer to each group's folder. Creating folders per department and assigning the project viewer role to department-specific Google groups at the folder level enhances and enforces consistent read-only access. A company needs IAM separation between prod and dev. What's the best IAM structure? Create folders for prod and dev, create Google groups and assign permissions at the folder level. So folders clearly separate environments like prod, dev, UAT, RC, and then Google Groups can manage permissions cleanly at the folder level, ensuring proper isolation and simplified administration. You create a new service account to list Compute Engine instances in a project following Google recommended practices. What should you do? Create a custom role with the permission compute.instances.list and grant the service account this role. A custom role ensures least privilege by granting the exact permissions needed. Compute.instances.list and nothing else. An engineer accidentally deletes a service account, breaking application functionality. What's the quickest secure recovery method? Use the undelete command to recover the deleted service account. Google provides the undelete functionality for service accounts deleted within 30 days, enabling quick, secure recovery without security compromise. You investigate a compromised service account key and need to audit new resources created by it. What should you do? Query your admin activity logs. Admin activity logs record resource creation and configuration changes, ideally for auditing resources created by service accounts. Your team must ensure a compute engine instance cannot access the internet or Google API's services. Which two settings must remain disabled? Public IP and private Google access. Public IPs, disabling those prevents direct internet access, and private Google access, disabling that, prevents internal instances without public IPs from reaching Google APIs or services. Which two implied firewall rules exist by default in every VPC network? Allow all outbound connections, deny all inbound connections. Why? Because Google Cloud VPCs will always include those two implied firewall rules. Allow egress, deny ingress, unless explicitly allowed or denied. A customer must restrict access to a 3-tier internal web app by CIDR, relying on native SYN flood protection. What product should they use? VPC firewall rules. These provide CIDR-based ingress control and inherently protect against SYN floods via Google's infrastructure-level protections. A company runs workloads in a private server room and needs to securely connect to GCP from internal networks. Which two products can they use? Cloud VPN and Cloud Interconnect. Cloud VPN establishes encrypted connections over the internet. Cloud Interconnect provides dedicated private connectivity, bypassing the public internet entirely. And I'd say Interconnect is a much higher bandwidth, much higher throughput, much more consistent. VPN is better for short term. Your org wants to centralize control of firewalls, subnets, VPNs with separate engineering teams. What's the best networking model? The shared VPC, host plus service projects. So with the shared VPC, this will allow us centralized network management with firewall, subnets, and VPNs via a host project, while service projects independently manage their own resources. Question 29. Shared VPC setup. How do you allow engineering group A to attach only to 10.1.1.0/24 subnet? A compute network user role at the subnet level. Assigning that network user role at the subnet level will restrict groups' attachment to that specific subnet. Okay. Your backend database must only be accessible from your front-end application, not other network instances. How should you design this? Create an ingress firewall rule using firewall tags. Firewall tags effectively restrict database access exclusively to the front-end app, isolating it from other network instances. Two companies build an app tier and storage tier across separate GCP organizations without public internet use. Which connectivity option do you use? VPC peering. VPC peering provides private internal IP-based connectivity between VPC networks, even across organizations, without public internet exposure. Front-end instances require public IPs. Other instances should not. Engineers have editor roles. How do you enforce this requirement? Set up an organization policy to permit public IPs only for front-end instances, because organization policies strictly enforce network constraints. So allowing selective IP assignment only to permitted front-end instances would be the best practice. What are two characteristics of VPC peering, security-wise? Non-transitive peering, meaning A connected to B and B connected to C, does not mean A connects to C. And peering between different GCP organizations, which means that if you have two organizations, you can use VPC peering to connect between them both without traversing the public internet. All right. Deploying multiple three-tier web apps, ensuring network separation between tiers. How do you do this? Run each tier in its own subnet with subnet-based firewall rules. Subnets combined with firewall rules provide secure, segmented network isolation between application tiers. Virtual machines need public repo access for updates. Current deny all egress rule is priority 1000. What should your team do? Create an egress firewall rule allowing traffic to the repository's hostname with a priority less than 1000. So a lower priority number has higher precedent, so creating an allow rule with a priority less than 1000 overrides the existing deny rule. Hostname managed base rule manages dynamic IP changes effectively. Analytics workloads must not access the internet or be accessible externally, but still reach the cloud storage. Which two strategies apply? You configure private Google access and avoid assigning public IP addresses. Private Google access allows internal communication without public IP exposure, and you avoid public IP addresses to assure that workloads remain completely internal. Virtual machines run batch processing, writing to cloud storage with no internet access allowed. How do you enable cloud storage access? With private Google access on the VPC. Because private Google access will grant secure API access to cloud storage without requiring the public internet. How do you allow a front end in subnet A to access a MySQL virtual machine on subnet B without other subnet VMs gaining access? A firewall rule based on unique service accounts. The service account-based firewall rules precisely restrict traffic between front-end and database virtual machines, ensuring robust and secure communication without broader access. Okay. An apps instance group deployed behind the standard tier load balancer needs expansion to second region with single external IPs for both regions. How is this done? Change the front-end configuration to the premium tier and add a new instance group. The premium tier network provides global load balancing with a single external IP across multiple regions, enabling efficient distribution of traffic. How do you prevent data exfiltration among dev, stage, prod workloads, but allow inter-project communication under an implementation folder? Well, create an access level and access context manager. Use a shared VPC for inter-project communication. The Access Context Manager, combined with the shared VPC, allows for controlled project communication and prevents unauthorized data exfiltration through defined parameters and perimeters. A customer needs to prevent attackers from hijacking their domain or IP and redirecting users to a malicious site via man-in-the-middle. How should they do this? DNS security extensions. DNSSEC prevents man-in-the-middle attacks by adding cryptographic signatures to DNS data. This ensures responses to DNS queries are authentic and haven't been tampered with. And without DNSSEC, attackers could spoof DNS responses and redirect users to malicious IPs. It's critical when the integrity of the domain resolution is part of your attack surface, especially for public-facing domains. How can an in-progress App Engine site be restricted to only customers and employees? Enable IAP, and allow Google Group identity ad proxy and allow Google Groups with customers and employees. IAP provides centralized access control based on identity and context, like group membership and two-factor authentication status. It's ideal for App Engine apps, allowing access only to authenticated users in a Google Group. App Engine firewalls are IP-based and don't integrate identity. VPNs or .ht access don't provide identity-based fine-grained control in GCP. How do you route users to the nearest mail server based on location? TCP proxy load balancing? Why? Because TCP proxy load balancers provide global load balancing for non-HTTP traffic, such as SMTP over port 25 or 587, and it uses the client's geographic location to route requests to the nearest available backend. Unlike HTTPS load balancers, which use layer 7, TCP is layer 4, making it suitable for mail servers. Okay, a customer wants to make it convenient for their mobile workforce to access a CRM web-based interface hosted on GCP. The CRM is only accessible from the corporate network. They want to expose it over the internet securely with two-factor authentication. Which product should be able to do this? The Cloud Identity Aware Proxy. IAP allows secure access to internal apps over the internet by enforcing IAM and two-factor authentication before users connect. It provides a zero trust access model, so users don't need to be on the corporate network, and works seamlessly with App Engine, GCE, GKE, and even hybrid environments using the IAP connector. A VPN would allow too much access and lacks fine-grained identity enforcement. An engineering team is launching a public web app hosted in multiple GCP regions, routing requests by URL. They want to avoid direct internet exposure and block traffic from known malicious IPs. Which solution should they implement? Cloud Armor. Cloud Armor sits in front of an HTTPS load balancer and acts as a WAF, web application firewall. It blocks bad known IPs, mitigates DDoS, and enforces custom rules based on headers, regions, URLs, etc. And it protects applications from direct exposure while enforcing security policies at the edge of Google's global network. Other options like NAT or load balancing don't provide that layer 7 threat protection. You're part of a security team that wants to ensure that a Google storage bucket in Project A can only be readable from your project or from Project B. Oops, there's that. You also want to ensure that data in the cloud storage bucket cannot be accessed from or copied to cloud storage buckets outside the network, even if the user has correct credentials. What should you do? Enable VPC service controls, create a perimeter with Project A and B, and include cloud storage services. VPC service controls prevent data exfiltration from Google managed services, even by authenticated users. When Project A and B are in the same service perimeter, access is allowed between them, but blocked from outside. IAM alone can't enforce or can't stop authorized users from copying data out to another project or downloading it locally. So other options like VPC peering or firewall rules control network access, but not API service level data flows. You want to implement envelope encryption and application layer encryption. What should you do? Locally generate a data encryption key, encrypt it with a cryptographic encryption key from Cloud KMS, and store both. The envelope encryption involves generating a data encryption key locally. The DA key can encrypt the data. The DEK itself is encrypted or wrapped by a key encryption key, and stored in Cloud KMS. You store the encrypted data key and the wrapped DEK. The KEK remains securely with Cloud KMS and never leaves. Okay. A customer using managed instance groups needs fast job completion and control of encryption keys. What should they use? Customer managed encryption keys with KMS. CMEK offers customer control over keys managed within Cloud KMS, and it provides full control over key rotation, deletion, and IAM permissions, suitable for scenarios like MIGs requiring rapid provisioning and uniform key management. How can Cloud Dataproc users manage symmetric encryption keys for persistent disks? With Cloud KMS to manage the DEK. Cloud Dataproc integrates directly with Cloud KMS, and symmetric data encryption keys for persistent disks are generated and managed via Cloud KMS, offering centralized key management. How can a team manage customer-supplied encryption keys for objects uploaded to cloud storage? Use GSUtil and specify the key. With CSEK, customers provide their own encryption keys, customer supplied, and the keys are specified explicitly on each API request, typically via GSUtil commands. Google Cloud does not persistently store CSEKs. You want compute engine disk data encrypted at rest using Cloud KMS with uniform IAM key permissions. What should you do? Create a single key ring for all persistent disks and all the keys in this key ring. Manage IAM permissions at the key ring level. Organizing keys with a single key ring simplifies IAM permission management. IAM permissions managed at the key ring level apply uniformly to all keys contained. This is ideal for consistent security policies. What are steps to encrypt data using envelope encryption? Generate a DEK locally, encrypt the DEK, encrypt the data with the DEK, use a KEK to wrap the DEK, and store the encrypted data and the wrapped DEK. Why? The envelope encryption involves generating the DEK locally, encrypting the data using the DEK, wrapping the DEK with a KEK, the key encryption key, and then storing the encrypted data and the wrapped DEK very comprehensively. Your company uses sensitive data and cloud storage and wants encryption using a key generated on-prem. What should you do? Use a customer-supplied encryption key to manage the data encryption key. CSEK allows using your own AS2256 encryption keys generated on-prem. Keys are directly supplied with each storage operation, ensuring control of encryption keys at all times. And Google does not store or manage these keys persistently. That allows a nice clean separation and responsibility on your end. To analyze employee bonus trends without exposing individual data, how would you do this? With its DLP technique. Crypto replace FFX FPE config. The format preserving encryption, FPE, is ideal when data must remain usable for analytics while protecting sensitive data details. It maintains the original format, length, and character set, enabling reversible pseudonymization for analytical purposes. How should a support org handle chat image uploads that may contain PII while still maintaining and following analysis? Use DLP API to redact PII from images. So the Cloud DLP supports image redaction by identifying and removing sensitive data directly within images. So it'll preserve the utility of the images for analysis and ensure sensitive data is removed. How can a retail app detect and prevent PII in user comments before publishing? DLP is specifically designed to detect sensitive data types or info types like PII. This can inspect text content in real time, enabling automated detection and redaction of or removal of sensitive information before publishing. A company running a web shop on Google Kubernetes Engine wants to analyze customer transactions in BigQuery. You need to ensure no credit card numbers are stored in BigQuery. What should you do? Cloud Data Loss Prevention API uses to redact the related info types before the data is ingested into BigQuery. So DLP can inspect the data before ingesting it. It'll identify sensitive info types like the credit card numbers and applies de-identification techniques like redaction or tokenization, preventing sensitive data from being stored in BigQuery. A company is backing up applications to a cloud storage bucket shared with both analysts and the administrator. Analysts should not access logs with PII. What should you do? Use Cloud PubSub and Cloud Functions to trigger a DLP scan on upload. If PII is detected, move the object to a restricted bucket. So Cloud Storage uploads can trigger PubSub notifications and Cloud Functions. Cloud Functions can invoke Cloud DLP to inspect new files for PII. Detected sensitive objects can then be automatically moved to a restricted storage bucket, preventing unauthorized access. To optimize Cloud DLP API usage and reduce costs for data stored in cloud storage in BigQuery with location indicated as a suffix, what cost reduction options would you recommend? The rows limit and bytes limit per file for sample data, and use cloud storage regex file set to limit scans. So limiting the number of scanned rows limit, and bytes per file, bytes limit per file, reduces data processed by Cloud DLP. Cloud Storage regex file sets limit scans to relevant files subsets, so it'll minimize the inspection costs without sacrificing protection. A customer needs an alternative to storing their plain text secrets in the SCM, source control management. What should they do? Encrypt secrets with CMEK, customer managed encryption key, storing in cloud storage. Storing secrets in plain text in SCM systems like your Git, Bitbucket, whatnot is insecure and can lead to sensitive data leaks. Cloud storage, Google Cloud recommends securely storing secrets using services specifically designed for secure data storage and encryption. Using CMKs to encrypt secrets and storing them securely in cloud storage provides a more secure solution, as it allows controlled access and auditing while maintaining full control over encryption keys. Applications often require access to secrets, pieces of sensitive data, to build or run time. The administrator managing these secrets wants to track who did what, where, and when within their GCP projects. Which two log streams would provide the required information? Admin activity logs and data access logs. Admin activity logs record administrative operations and changes in configurations, like creating or updating secrets in Secrets Manager. Data access logs specifically record operations related to accessing or using secret data, like retrieving a secret's value. Together, these two log streams provide the comprehensive information for auditing. Admin activities show when secrets are created, modified, or deleted. Data access logs show who accessed the secret and when, crucial for maintaining accountability and auditing for compliance. A bug previously caused a malicious script to crash a VM. The bug is fixed, but you want to be alerted if it happens again. Stack driver alert on CPU usage. Basically, you want to use your cloud logging and monitoring. If anything goes over 80% CPU usage, you'll be alerted. The symptom of it was likely caused by the CPU usage. Using or setting a stack driver CPU usage threshold is a proactive monitoring approach. Unlike log-based alerts, which may lag, or scheduled big query logs, a CPU usage alert fires immediately when a threshold is breached. Your team wants unified logs from all dev projects in the non-prod folder using ABC billing account into your SIM. How would you do this? Create a cloud storage sync from billing accounts /ABC-billing for SIM ingestions. Why? Because cloud logging allows for log syncs at the billing account level to aggregate logs from across all associated projects. And by setting the sync at the billing account level and sending to cloud storage, the SIM can ingest logs from a single centralized location. How do you reliably export logs to an on-prem SIM? Export logs via org sync to a pub sub, to a data flow, to a SIM. So pub flub to data flow is a recommended method for streaming logs in real time to external systems like a SIM. You create an organizational level log sync that matches all the logs you need. And then data flow, which is a serverless pipeline service, can transform and route your logs securely to the SIM. A manager wants to start retaining security event logs for 2 years while minimizing costs. You write a filter to select the appropriate log entries with cloud storage buckets. So lifecycle policies. Cloud storage is ideal for long-term retention, offers lower costs for cold storage tiers like Nearline and Coldvine, and you can create a log sync to cloud storage and set lifecycle rules to reduce storage costs over time. A new App Engine app writes logs to BigQuery, and if you want to confirm the only App Engine default service has write access, BigQuery, select the dataset and confirm that App Engine default service account is the only account with write access. Because BigQuery IAM policy bindings will determine which identities can write. To validate the write access, you must check the BigQuery dataset's permission, not just the logs. When creating a secure container image, which two items should you include? The single app per container and remove unnecessary tools. So the single app per container, do this because it follows the one process per container design principle to limit complexity, improve observability, minimize the attack surface. And the unnecessary tools, you can strip stuff like curl, bash, or vim to reduce the number of potential vectors an attacker can exploit post-compromise. So it'll align with minimal base image practices. Your DevOps team is deploying an internet-facing container to GKE. What you do to minimize the attack surface. Build small containers using small base images. This aligns with attack surface reduction by minimizing the container's footprint, fewer binaries, fewer vulnerabilities, and examples include a distro list or scratch base images. You're migrating a legacy app with unknown ports and no docs. What's the safest approach? Migrate it to an isolated project. allow internal TCP traffic, and use VPC flow logs to analyze this. This is because it strikes a balance between isolating the project to reduce a blast radius and allowing internal TCP traffic to get the app up and running. VPC flow logs will give insights into which protocols and ports the app is actually using, and this will be critical for hardening the environment post-migration. How can InfraOps keep Windows Compute Engine VMs patched? Throwing them away. Reboot all VMs during a maintenance window and let startup scripts download patches. This is programmatic or pragmatic and aligns with how Windows updates are typically managed when there's no Active Directory or Windows SUS server. Startup scripts can run Windows Update during the boot process. A new vulnerability is found. How should the team update running GKE? How should the team update running GKE containers? Update the app or base image, rebuild the container, and redeploy. Containers are immutable. To fix a vulnerability, you must patch the code or base image, rebuild the image, push it to the registry, trigger a deployment to roll out updated containers. And this is the standard. Customer deploys an application to App Engine and needs to check OWASP vulnerabilities, Cloud Security Scanner, or maybe Security Command Center too. The Web Security Scanner, formerly known as Cloud Security Scanner, is built to automatically scan web apps on App Engine, GKE, and Compute Engine. It'll detect OWASP top 10 vulnerabilities like cross-site scripting, SQL injection, and a number of other things. And it can be used without code changes, either as managed scans or custom scans. It's the best choice for App Engine environments looking to find per application layer vulnerabilities. A GKE hosted staging web app dynamically includes unvalidated user input to web pages, potentially leading to cross-site scripting. How should you prevent and fix this vulnerability? Use Cloud Armor, especially the web security scanner and staging in a template system. Cloud Armor provides layer 7 DDoS protection, WAF, and it blocks known malicious payloads, including common cross-site scripting patterns. It's useful in production to defend against real-world threats in real time. It's not a remediation, but a good buffer. While it doesn't fix the vulnerability at the code level, it mitigates the exploitation in production. So here's an explanation. Web Security Scanner can simulate cross-site scripting payloads against your staging environment and help detect whether your app can sanitize or escape user input correctly. And you can use a template system to support contextual auto-escaping. So it'll prevent cross-site scripting by default escaping user inputs in HTML, JavaScript, or attribute concepts. This is the real code fix level for cross-site scripting vulnerabilities. Company uses Cloud Identity Aware Proxy for ERP hosted on Compute Engine. Security wants to only accept traffic from IP. What must ERP validate? The JWT assertion. So Cloud Identity Aware sits in front of applications to provide identity and context-aware access control. When IP forwards traffic to a backend, like an ERP or a Compute Engine, it includes a signed JWT assertion in the HTTP headers. The ERP system must validate this JWT token to ensure the request originated from the IP, the token hasn't expired, and the user is authorized. Validating only identity headers without JWT verification can lead to spoofing vulnerabilities. Data scientists want to use GCP, but require SAML SSO and own the domain, which is already in G Suite. How should the systems engineers proceed? Ask Google to provision super admin rights to the data science manager. Since the domain is already claimed in G Suite, another team, like IT or security, manages or likely manages the super admin access. To configure SAML SSO in GCP, super admin rights are required. So instead of registering a new domain or contesting ownership, the proper path is to request Google support to grant the necessary admin role to the responsible party, like the data science manager, if internal access is blocked. What GCP solution is best for migrating backup or disaster recovery workloads, while production remains on-prem? BigQuery, using a data pipeline job with continuous updates. So BigQuery is ideal for data warehousing and analytical workloads. When in backup, disaster recovery scenarios, large data sets can be mirrored into BigQuery from on-prem databases for queryability during outages, long-term archival storage, and continuous data pipeline updates to ensure data freshness, even if production remains elsewhere. You need to comply with data privacy rules by automatically deleting PII after a specific timeline. What should you do? Store the data in a single BigQuery table and set the appropriate table expiration time. BigQuery allows setting table expiration times, automatically deleting data after a defined interval, and this is a built-in feature for compliance automation. Persistent disks and Bigtable don't offer a fine-grained time to live deletion at this level without extra scripting. You need long-term data storage that replicates across at least 2 geographic regions. What makes the requirement? BigQuery. BigQuery datasets can be stored in multi-regional locations for automatic geo-replication, and this ensures availability, durability across regions like the US, EU, Asia. SSDs and persistent disks do not replicate automatically across regions, so you got to back it up. And Bigtable can replicate, but not all tiers offer it by default. Clients connect to your app on port 587 using TLS. TLS termination must happen at the load balancer. Which load balancer type should you use? SSL proxy load balancing. This is because it terminates TLS at the load balancer and supports non-HTTPS protocols like SMTP on port 587. You want to restrict which project's images can be used to create compute engine boot disks. What should you do? Use an org policy with compute.trustedimage.prod or trusted image projects. Deny all except trusted. Why? Because compute.trustedimage projects is an organization policy constraint controls which projects can supply images. By denying all but a trusted project, you ensure only pre-approved base images are used. It's vital for hardened deployments. This restricts image uses at the org level and helps maintain compliance. PCI pods must run only on PCI non-compliant nodes and vice versa. How do you enforce this? Taint the nodes and add tolerations to the PCI pods. Taints prevent pods from scheduling on a node unless the pod has a matching toleration. This is the best way to enforce exclusive workload placement, like only PCI compliant pods on PCI nodes, and node selector, not sufficient on its own as it doesn't prevent non-PCI pods from running on those nodes. To comply with FIPS 140-2, how should you secure UDP communication and cache storage in your messaging app? Encrypt all cache storage and VM to VM communication using the boring crypto module. Because FIPS 140-2 compliance requires using cryptographic modules validated by NIST, and Google's boring crypto is a FIPS validated module. It works with UDP and other transport protocols, unlike TLS, which is generally TCP only. Boring crypto can secure data at rest and in transit, covering both cache and communication. Your org is migrating disaster recovery workloads to GCP first. Which GCP solution should you use? Cloud storage using a scheduled task in GSUtil via Cloud Interconnect. What? Because cloud storage is ideal for backup and disaster recovery due to its scalability, durability, and lifecycle policies, and GSUtil can automate uploads. Using Cloud Interconnect ensures reliable, high-throughput connectivity to support backup transfers from on-prem services and systems. Okay, your company runs App Engine apps. What's your primary security responsibility? Defending against cross-site scripting and SQL injection attacks. Because App Engine is a platform as a service, so Google manages the infrastructure, operating system patching, and networking. Customers are responsible for application logic, input handling, preventing code-level attacks like cross-site scripting, I can't remember CSRF, and SQL injection. You manage 3,000 cloud storage objects and want centralized IAM access and audit logging. What should you do? Use uniform bucket level access and IAM. Uniform bucket level access disables per object ACLs and centralizes permissions at the bucket level via IAM. This simplifies access management and auditing. Cloud audit logs integrate cleanly with IAM, not with object level ACLs. These are the questions that we've addressed. I hope you like it. We'll try another round. Hope you understand that these are related to the materials covered in the earlier audio book. Outside of that, I hope you have a good day. Thank you for joining.